So we're going to look at prisms, which is a solid, so it just means like a 3D shape, so what we mean by solid, okay? With two bases that are congruent. So that means like this bottom triangle is the same as the top triangle, okay? And they are parallel. So what you'll do there is you'll find, so surface area for prisms, you find the area of all the sides and add them all together. Sides, you can also think of, technically the word would be faces, but so like this one, how many different sides would this triangular prism have? Like it has the top and the bottom, so that's 2, right? And then how many sides would it have around that? What? Not 2 more. 3 more. So then total you would have 5 different faces. So you'll find the area of each one and add those all together, okay? So it's not hard in terms of the math part, it's just a lot to kind of keep track of sometimes, all right? Now a cylinder is still a prism, but what's the shape of its base? A circle, okay? So you will find, zoom in here. To do that one, you're going to do the area of the rectangle, because if you actually like unfold a cylinder, the side part there, this is a rectangle, okay? So you'll do, if you look at this, you draw this here. You may have seen this when you were in middle school. They did what's called a net shape. So it's like if you flattened out that 3D shape, it has 2 circles and a rectangle, okay? But what's tricky on a cylinder is what is this distance gonna match up to? It has to match all the way around the what? The circle. So that distance there is actually the circumference of the circle, okay? So anyone remember circumference formula? Oh, that's area. Pi r squared is area. 2 times pi times r. Yes. So we'll do, for the area of the rectangle, you'll do 2 pi r times its height, which is just how tall that is, and then the area of both of the circle bases. So what's the area for a circle? Pi r squared. And then why do you think this 2 is on here? Why are we going to do 2 times? Derek? Right, they're going to be the same because we said earlier prism means they're congruent. So this top is the same as the bottom. Okay? So like I said, it's like doing surface area is doing a lot of area and putting it all together. Okay? So it's not hard, just a lot to keep track of. All right. So this one says classify the following figures as prism or cylinder. I want you to be specific though, okay? So let me show you what I mean by this. Like if it's a prism, tell me what shape prism it is. It's like the first one. What shape is it? Rectangular prism. And that will be important because you have to do the area of the base, so I need to know the area formula for a rectangle. If it were something else, I use a different formula. All right, what's this second one here? Cylinder. Ooh, what about this one? Yes, so it's a trapezoidal prism, technically. If you just put trapezoid, that's okay. Trapezoid prism. Don't just put trapezoid. But. Okay, and then the last one, so count the sides. So the base is whatever shape we're talking about. So like technically, if you look at the trapezoidal one, so the actual base is whatever that shape you said is. So you said trapezoid. So the trapezoid part is the base. So this is actually like sitting on its side. Okay? It's like if I take this, what's the base shape? A circle. Does the shape change if I turn it on its side? No. The bottom is still a circle. It's just sitting on its side. Okay? So that's kind of where that's coming from. So this one, look at the shape. Count the sides. How many sides is that? 5, which is called what? Pentagon. So we would say a pentagonal prism. Okay. So remember, whatever shape that we would have named it or classified it as, that's the base. So sometimes when we're going to do the height, like, you can kind of label one here. Like this one, it's just the height is how tall it is, right? But on this trapezoid one, it almost looks more like the depth, like how far back it goes. It's still called the height because it's on its side, but just something to keep in mind there, okay? All right, so let's find the surface area here. All right, so if we are looking at our surface area for a prism, all we're going to do is find each side and add them all together. Like I said, keeping track of everything is the hard part here. Please try to stay organized. I'll show you how I organize it. If you have a different way, that's fine, but really focus on keeping it organized. So on number 1, what shape would the bases be? Triangle. So it is on its side. Okay, so I always draw the shape of what I'm finding. I don't know, it's just I'm a visual kind of organizer, so that's how I do it. How many of those triangles will there be? 2. So I write a 2 in there to keep track of it. All right, now I'm going to do my formula. I'm doing area, right? Surface area. So what if it's triangle? I'm going to do 0.5 times, let me turn this up a little. Oh, it's all the way. What is the base of the triangle? So looking at just the triangle right now. 12. Okay, now be careful on this. What is the height? Nolan? Yes, because we got to look for that 90 degree. Even though it's shown on the back triangle, those triangles are congruent, okay? So I can use it whether it's labeled on the front one or the back one. Okay, so type all that in. And I usually do, actually just do all that, and then I'll show you. All right, what'd you get? 24.6. So, and then how many are there? 2. So I just leave my answer on my calculator and click times 2. Which gives you 49.2. Okay, and then I usually just kind of box that, so I know that part's done. Okay, a triangular prism, we got 5 faces, so we've done 2 of them. What shape are the side faces? Rectangles or squares, yeah, we kind of got to look at them. Are any of them congruent? Can you tell? No, they're not. And the reason is this is not an equilateral or isosceles triangle. So I know all the sides are different, so all the rectangles are going to be different. Okay? So those you'll have to do individually, but rectangles are quick. So I'm going to look at this side one first here. I'll try to color them so you can see what I'm talking about. So I'm going to look at that one first. Okay? What 2 measurements am I going to multiply for the area of that rectangle? Like what are so what's this side? 5. And then how far back does it go? 3. So that would give me, and there's one of those, sorry. So that gives me 15. Okay. Now, quick thing to know, if this was 3, do I know this? What is it? Also 3. And then the one over here, well, I probably won't need that one, but all of those depths would be 3, okay? All right, so let's look at the big one here. Oops. Let's look at this one. There's still just one of those, right? And what 2 measurements would I multiply? So it's still, the depth or the height is still 3, but what would its base or its length measurement be? 10. So that gives us an area of 30. Okay, and then, am I done yet? No, and one way to keep track is I've done 2, 3, 4 faces. I know I need 5. So like, oh, I always kind of double check those and make sure I've included them. So I need one more, and it's this one on the bottom here. So what measurements am I going to multiply for that? 12 and 3, which would give me 36. Okay, and then last step. So if I was going to paint the outside of this shape, would I paint all of them? All of those faces? Would I include them all?
No.
Why not? Technically for this one we will. Once we get into like a house or something, we wouldn't paint the bottom, right? So what are we going to do with all of those areas then? Add them up. So you're going to add all of these. We kind of only have 4 because we did 2 on the 49.2. So we already sort of simplified that one. So add all those up. And I would use one of the calculators where you can see what you've typed. I would not use your phone one because then you cannot tell like if you made a typo. Because there's so many numbers it's easy to lose track. So what, someone tell me what you got. 130.2? You get that? Good. So I'm going to write SA for surface area. It's still area, okay? So we still label it kilometers squared, or whatever the units are. Okay. Okay, so if we look at number 2, what is the base shape on 2? The one that there's only 2 of. See if that helps. What would, like, if you notice there's 4 rectangles around the sides, but what is there only 2 of? The trapezoids, so here. So those are our bases, okay? So I'm going to have 2 of those. All right, what is the formula? It's like I do half times height, right? Which is, what's the height of that trapezoid? 12. And then I do, you don't have to have the times actually, just do parentheses. What do I do inside the parentheses for a trapezoid? Base, add the 2 bases. So, David, what's one of the bases on the trapezoid? Okay. Brendan, what's the other one? Look up here. 23 is the bottom one. What would the top one be? 18, because it's the same as that back there. Okay, so I would do that answer. So whatever that is, you can come back to that. Type all that in, see what you get. All right, so what did we get for the trapezoid before you multiply it? 200 what? Even? Yeah. Okay. And then if there's 2 of those, what should we do now? Multiply it by 2, just to kind of save us a little work later. So what would that give us then? Okay. And I like to just kind of box it or circle it because then I know, okay, I'm at least done with that part. All right, now how many different rectangles am I going to have? 4. Where's that? Because it's going to be the same, like there's 4 sides of this trapezoid, right? So there's going to be 4 rectangles around the side.
Is the top not much square?
The top might be, no, it looks like it, but it's not quite. So what is, look at these black lines I'm drawing there. What are all of those? And we're going to think of that as like the height or the depth, remember? What are all of those going to be? 15, because they tell us this one on the right. So all of these are 15. Okay, so let's do, try to just start on one side and like work around because it's easy to lose track of one. So if I do that one, 15 times, what's the other side? 12. So 15 times 12 is what? Okay. And then what one can I do next? The top one, sure. So we'll do this one now. And that one's going to be 18 times 15, yes. Which is 270. All right, and all of these are different, so I do need to make sure I do each one, not just like times 4 or something, okay? Let's do this one over here now. So that one's going to be 15 times what? 20. Which is 300. Okay, and then last one is where? The bottom. What will that one's measurements be? 15 times 23. So that's our biggest one there. And that's 345. Okay, so last step, I want all the exposed area is I add all of these. And then just double check that's 2, 3, 4, 5, 6 spaces, which is right because there's 2 bases and 4 sides. So add all of that up. It's pretty big. Dixon, did you get it?
Yeah.
What'd you get?
1587.
Yes, that is correct. Ooh. Okay. All right, what is different on 3? What shape is this? Cylinder. Okay, and this is probably your longest formula. So if you need to look at the top, if you did not get the top formula filled in, remember it's always on the back as well. Okay, so surface area, SA, equals, so I'm going to do the area of the rectangle part, so like this, is the circumference times the height. So I'm going to write it first before I plug in, because I know this is a long one to remember, okay? So circumference is 2 pi r, and height is h. Make sure I'm writing it the same as on the formula sheet. Oh, they put it the other way, but that doesn't matter. On your formula sheet, it's flipped, but either order. Okay, plus I have to add the area of the 2 circles. So area of a circle is what? Pi r squared. But why is this 2 going to be on there? There's 2 circles. Okay, so reminder. So just either look at this or write it down, whichever you feel like you'll remember better. This part is representing the what? What part of the cylinder is that? The rectangular piece around the side. Okay, because we do the circumference, which is all the way around it, times how tall it is. Okay, and then this part, you said there's a 2 on there because it's the area of the 2 circles. I think there's a question similar. It's like asking you to explain why there's a 2 or something like that, okay? So I'm just trying to show you like where those are coming from. All right, now let's try it. So you can plug all of this in at once. If you want to do it separately and add them together, that's fine. So let's look. So 2 times pi. I do need to plug in for r. Do they give us r? Yes. And let's just write, if that's r, write r equals 11. If they give us diameter, then make sure you have it. So 2 times pi times 11 times what would the height be? 26. Okay, I want to put plus, but let's like do all of this, and then we'll do this other one. So we'll plug it in, and then we'll kind of do them separately. So the second part, 2 times pi times r squared, because that one's for radius. Okay, so do like the teal part and the purple part, and then we'll get your final answer, okay? All right, so just to check, you can do this all at once with the plus sign. So if you feel more comfortable doing that, go for it. I know some of you just like to multiply out parts, and that is fine as well, okay? So I'm fine with either. So if you did it separately, you would do the first part is 1796, oh, no, turns it to 97 if you round it, because it was 0.99, okay? And then the other part, so the area of the two circles would be 760.3. Do you get that? Yes. Okay. So if we add those, you get 2,557.3. If you do it all at once, okay, like if you just type all of this at the same time, which is fine, you can do that, then you're just going to get 0.2 instead of 0.3. Is that what you got, Grace? Yeah. So that is okay, kind of like last unit. If it's off by a tenth or so,
we round it because it's a 5.
Oh,
so
okay,
it would
good.
be 3.
Yeah, perfect. Grace said that one came out either way, so good. I thought someone showed me a different one. It might be off by a little tenth on some of them, depending when you round, okay? And that's all right. Okay, for sake of time, since we're on shortened schedule today, I'm gonna skip 1, but do 2, okay? Because these are long ones. These are kind of combined. So skip 1, do 2. Please don't skip these in your homework, and that way if I have a little extra time, I can help check in with some of you on maybe what you need help on the homework. So these are considered composite surface area because that's just 2 of them stuck together. Again, composite is more like real life, okay? Typically, a building, if you're painting or something or putting on siding, doesn't just have like a rectangular prism, okay? There's maybe triangular prism on top for the roof or multiple, okay? So find the surface area of each composite shape. Keep in mind, the unexposed faces are not included in the total surface area, okay? So you may need to subtract those from the total. All right, so let's look at what I mean by that. So on number 2, so think if you took this shape, so this part is think it's like glued onto that bottom, okay? If I took this whole shape and I dunked it in a big thing of paint, all right, which part would not be, the bottom here would not count, and also that part in the top of that cylinder. So I'll have to not include that bottom. So I'm gonna not include the bottom of the top cylinder, like David said. And also, I'm gonna subtract that from the top of the bigger cylinder, I'll say. Okay, because it's sitting on top of that, so that portion of that top cylinder won't be exposed either. Okay, so does that make sense, or ask me what questions you have on that part? That's usually the toughest part. Yes. Yes, it does. Okay, so that, just make sure you think about that part. That can be that's pretty much the toughest, is thinking about what do I not include. Okay, now just find the surface area. So here we have 2 shapes that are the same, but they are different sizes, right? So let's do the surface area of the small cylinder, or the top one. Okay, so surface area for a cylinder is what? SA equals 2 pi r times height. Right. So remember, this is for the rectangle, this is for the two circles. That is your longest formula to memorize, but I feel like if you think of it as like, oh, the rectangle and then the two circles, it makes more sense to kind of break it up that way. All right, so let's just go ahead and plug into all of this one for, just to be quicker. So 2 times pi. Oh, let's look up here. Ooh, we did not have the radius. Fun. So we got to find this radius first. So let's look here. All the way across here is 38, right? Okay, David just said 12. What'd you do?
13 and 13 got 26.
Good.
38 minus 26 got.
Yes. And if you didn't see, let me erase this real quick. See the little markings here? Like this one means that one's also 13. Is that what you saw?
Yeah.
Okay. And you kind of looks like it's in the center, right? So 13 and 13, David says 26, and then 38 minus 26 gives us what? 12. Okay. The radius actually isn't 12, but you're really close. That is the what?
Oh, on the top of the shape.
So that would be the diameter, right? So what's the radius then? 6. Wasn't that fun? Good job, David. Okay, so I'm going to plug in times 6. Okay. How can we find the height of that cylinder? A lot of missing parts here. 23 minus what? 14, because this is 14, this is 23. What's 23 minus 14? 9. So that is the height. I'll put equals h. So times 9 plus 2 times pi. Did we already find the radius? Yep, so that's 6 squared. Okay, type all of that directly into your calculator. Please type on one where you can see what you've typed, because that's a lot of numbers to lose track of. Okay, should have got 565.5. All right, so that is the small cylinder. But, oh, you didn't? Let me come look in a sec. One thing here, there's a few ways you can do surface area when you're not including something. I went ahead and did it, and then I subtract out later. I could do, like, since we said the bottom circle isn't going to be counted, you could take the 2 off of here. Okay? I'm going to figure it and take it out later, actually. But you can do it both ways, and sometimes I switch it up. So let's come back to that part. So the large cylinder. Okay, surface area equals 2 pi. Now, what is the 38 is the what of that circle? Diameter. So what would I do to get the radius? Divide by 2. So it's half of 38. Yes. So the radius is 19. Always make sure you're checking that you have that. So 2 times pi times 19. What's the height of the cylinder? The big cylinder. 14 plus 2 times pi times radius squared. So 19 squared. Okay, so type in that whole thing and see what you get. I'll do it too. Okay, you get a very large number. So I got 3,939.6. I also typed the whole thing and then clicked the wrong button at the end and had to start over, so that was fun. Yeah, I clicked like log or something on my calculator, like crap. All right, so this is the big cylinder. So always think back to this part. So composite surface area, I actually think is the hardest of what we do this whole unit. So we're doing the hard part today and then it'll get easier. So remember to think what was not included. So the bottom of the top cylinder, right? So we need to find that area real quick so we can subtract it out. So the bottom of the top cylinder is just a circle, right? So what would the area be then? Area equals pi times, top circle had a radius of what? 6 squared. So what's pi times 6 squared?
113.1.
What was it?
113.09.
Okay. So that is this one, right? How many of those, so watch closely here, it's the hardest part. How many of those do I need to take out of my total? 2 of them, because it's taking out of the small cylinder and out of the big cylinder, okay? So I'm going to read that as a negative. And then one more. So you can either do it again or you can do it times 2. Let's do it times 2 actually. So what's 113 times 2 would be 126.2? Okay. So I just type it as a negative then when I'm combining everything. Question?
Wait, no, it'd be 226.
Oh, yes, you're right. Thank you. Brain fart, huh? Good job. All right. So take this, take this, take this. So only thing, what am I going to do with these 2 down here? Add them, because they're positive. And then this one I'm going to subtract it. Okay? So figure that total then. Okay, when you are done, I want you just to raise your hand and I will check your answer and give you your homework. You have the 7.2 homework and homework check today. Okay, if anyone did not get done, you have to combine the negative 226.2. I did see a couple people leave that positive or didn't click minus. The 565.5 and the 339.6. So I would type that in like plus 565.5 minus 226.2. Okay, which should have given you 4,278.8 millimeters squared. And you just write SA, someone had asked that. So if you did not have that done, get that finished on your paper. I want to see both parts written if you did not do it on your own. And then raise your hand, I'll give you your homework.